Hello students, welcome to the lecture of Structure of Atom. In the last lecture, we had studied about the drawbacks of Rutherford's model, which were that if the electrons move in a circular orbit, then they should emit radiation which will lead to the formation of a spiral pathway, and gradually the electron will sink into the nucleus. And the second drawback of Rutherford model was that the electrons, if they are considered to be static, then also there will be no centrifugal force, and due to the attraction of the nucleus, they will sink into the nucleus. So, after these drawbacks of the Rutherford model, later on Niels Bohr modified this model and proposed Bohr's model. But before going to Bohr's model, we need to know about some factors on which Bohr's model was dependent on. Bohr's model was developed on the basis of these factors. One was the wave particle duality of light, and the second one was the atomic spectra. So, we were studying about the wave nature of light or wave nature of electromagnetic radiation. Why? Because light has two components, electric component and magnetic component. That is why it is called electromagnetic radiation. And we had studied about the three major factors of electromagnetic radiation, that was wavelength, frequency and speed. So, we had studied speed, frequency and wavelength of light. Speed is denoted by c, and the speed of light is 3 into 10 to the power 8 meter per second in vacuum. We had seen that speed of light does not need any medium to travel. Light can travel through vacuum, and the speed of light changes in different mediums. Changes in different media. Okay. And the frequency is denoted by nu, and the unit of frequency is hertz or second inverse, because frequency is the reciprocal of time. And wavelength is denoted by lambda. The unit of lambda is meter, but generally it is written in nanometer and angstrom. Nanometer is 10 to the power minus 9 meters and angstrom is 10 to the power minus 10 meters. And the relation between these three factors is C equal to nu lambda. So, along with these three factors, we had seen the relation of speed, frequency and wavelength, that was C equal to nu lambda. So, what is nu? Nu is C by lambda and lambda is C by nu. So, there was one fourth factor, that is called wave number. It is denoted by nu bar and written as, its SI unit is meter inverse, but it is generally written as centimeter inverse. So, wave number is the reciprocal of length, that is wavelength. So, nu bar equal to 1 by lambda. So, the formula of nu bar will be, if this is lambda, then nu bar is nu by C. So with these relations we had started one numerical. This was the numerical, that lambda of green light is suppose 550 nanometer. So what will be its frequency and wave number? This is the wavelength, 550 into 10 to the power minus 9 meter. This is lambda, and we have to find frequency nu. So nu is equal to c by lambda. Therefore nu equal to c by lambda, 3 into 10 to the power 8 meter per second by 550 into 10 to the power minus 9 meter. So meter will cancel out. So 3 by 550 will be 0.00545 into 10 to the power 8, and if we reciprocate this, then 8 plus 9, so 10 to the power 17 second inverse. So if we write it properly, then it is 5.45 into 10 to the power 14 second inverse. That is, we can write it as 5.45 into 10 to the power 14 hertz, right? Generally hertz is written, so we will write in hertz. And wave number, what is wave number? 1 by lambda. So 1 by 550 into 10 to the power minus 9 meters. So this will come as 0.00181 into 10 to the power 9 meter inverse. So this will come as 1.81 into 10 to the power 6 meter inverse. Okay. Now we had discussed that the electromagnetic radiations have different types of radiations in it. Light is not just the visible light that we are able to see. There are various other components of light. Visible light is just a very small range of wavelengths that is detectable by human eye. So there are various other components like the gamma rays, X-rays, ultraviolet, that is UV, visible, IR, that is infrared, radio waves, microwaves, etc. So all these types of radiations together is known as electromagnetic spectrum. So electromagnetic spectrum can be written like this. If we take a line, say these are gamma rays, then X-ray, UV, visible is a very narrow part, then IR, microwave and radio waves. Okay, so this is called electromagnetic spectrum. These different types of radiations have different properties. Okay. Different radiations have different properties. So they are basically divided according to their frequency and wavelength. Okay, so let's start with gamma rays. Gamma rays has a wavelength less than 10 to the power minus 3 nanometer, and the frequency ranges up to 5 into 10 to the power 8 to 5 into 10 to the power 22 Hz. This is the range of gamma rays. Gamma rays are produced by radioactive decay of the nucleus. Radioactive decay of nucleus, and they are detected by photographic film and ionization chambers, etc. Okay, so we had read about gamma rays previously also. So these are the gamma rays. It's a part of the electromagnetic spectrum. Next is X-ray. I'm sure everyone has heard of X-rays. X-rays have a wavelength of 1 nanometer to 10 to the power minus 3 nanometer, and the frequency range is, this is the wavelength range, and the frequency range is 10 to the power 16 to around 3 into 10 to the power 21 Hz. Why are we writing the wavelength in opposite order? Because frequency is inversely proportional to lambda, right? Frequency is inversely proportional to wavelength. So if we are talking about the frequency in an increasing order, then we have to talk about the wavelength in decreasing order. Okay, so X-rays are produced by inner shell electrons. They are detected by photographic films and gigotube. Now the next one is ultraviolet or UV. UV rays are, you know that UV rays are very harmful, and the ozone layer protects us from the UV rays of the sun. Ozone layer protects us from UV. So the wavelength of UV is from 400 nanometer from 400 nanometer to 1 nanometer. This is the wavelength range of UV, and the frequency range is 8 into 10 to the power 14 to 8 into 10 to the power 16 Hz. UV is produced by inner shell electrons moving from one energy level to another. And they are detected in photocells and photographic films. UV has lots of applications. UV visible spectroscopy is also a very important detection technique. Thank you.